Hello, Algebra 1 students. So we're starting a new chapter. This is going to be chapter 10. And the first section of the chapter is going to be about adding and subtracting polynomials. All right. And so polynomials might be a word that you hadn't heard before, haven't heard of, but it's something that we should be familiar with. All right. So let's just talk about what the definition of a polynomial is. So a polynomial is just an expression that is the sum of terms with exponents that are either positive or zero. Positive or zero. All right, so an example of that would be like 2x cubed plus 5x squared minus 4x plus 7. So that's an example of a polynomial. Other examples would be like x plus 3 or x squared minus 3x plus 5. Okay, so these are things that we've seen before, the things that we're familiar with, and so all we're going to be doing in this section is adding and subtracting. All right, there's a few other things that we need to define before we move on, and one of them is the degree of a term. All right, and the degree is just the exponent on the variable, the exponent on the variable. So let's look at the example that I wrote up above here. We have 2x cubed, so the degree of this term would be 3. The degree of this term is 2. The degree of this term is 1. And then the degree of that last term is 0. All right. And the degree of the polynomial, so we talked about the degree of each individual term, but the degree of the polynomial is the highest degree of all its terms. Highest degree of all its terms. So like this would be an example of a degree 3 polynomial. This over here would be an example of a degree 1 polynomial, and this would be an example of a degree 2 polynomial. And understand that we don't always need to write the biggest term out in front, okay? So it doesn't matter if the biggest term is at the end of the expression, in the middle of it, all right? It's just whatever the biggest exponent is, okay? And then standard form of the polynomial, that just means that the polynomial, the terms are written in descending order. Descending order. So all of the examples that I've written up here are in descending order because it goes the highest exponent first, second highest, and then it keeps going down. All right, so we can see that the biggest exponents first, and then they go in descending order. And the leading coefficient is the coefficient of the term with the largest exponent, okay, or the highest exponent. So again, looking back at the example that I have up here, the leading coefficient would be 2 because x to the third power, that 3, that's our highest exponent. So the number in front of that is our leading coefficient, which is 2. So we talked about what the degree of a polynomial is, and it's the highest degree of all its terms. So what we're going to do is we're going to classify polynomials by their degree. So the first example is just 5, but we can actually write this as 5 x to the 0th power. Because remember that anything raised to the 0 is 1, so this is really 5 times 1, which is just 5. All right, so then that means the degree here is 0 because we're looking for the highest exponent of all the terms. And then how we would classify this is just a constant. Okay, it's just a constant. So no matter what x is, 5 isn't going to change. It's always constant. Right? In the next example, the highest degree is 1. Remember, if we don't have an exponent written on the x, there's really a 1 hiding where the exponent is. Okay? And this is linear. We classify that as linear. All right? And in the second example, again, the degree of the polynomial is the highest degree of all its terms. So once again here, the highest degree is 1 and is also linear. All right, in the third example, the highest degree is 2. So when the highest degree is 2, Okay, we kind of talked about this at the end of chapter 9. Okay, when the highest degree is 2, this is a quadratic. Quadratic. So these are the types of equations that we can use the quadratic formula on. All right, and then next we have the highest exponent is 3. So this is known as a cubic, which makes sense because when we raise something to the third power, we're cubing it. All right, and then if the highest degree is 4, like we have here, this is known as a quartic. So this is what it means to classify a polynomial by degree, but we can also classify polynomials by the number of terms that they have, all right? So in this first example, we have 3x to the 5th power, and we have one term here, okay? So number of terms is 1. So because we only have one term, we classify it as a monomial. Monomial. All right, and a monomial is a polynomial with one term, okay? Mono means one. All right, the next one we have 4x minus 7. So here we have two terms. So if we have two terms, this is known as a binomial. Think of like a bicycle as two wheels, a binomial, two terms. All right, and it's a polynomial, yeah, polynomial with two terms. Okay, and a polynomial with three terms, you might be able to guess, is a trinomial. Okay, polynomial with three terms. Like a tricycle has three wheels, a trinomial has three terms. Okay, and the next one, here we have four terms, but after we get four or more, we don't have a special name for them anymore. They're just called polynomials at that point. Okay, so all of these first three are also polynomials, but based on the number of terms they have, they get special names. Okay, but if we have four or more terms, it's just called a polynomial. Okay, so there is no special name. Okay, polynomial, not polynomials, sorry, just polynomial. So let's practice identifying some of these important things for each of these polynomials. All right, so let's start with the first one. Okay, so degree. So that's asking us what is the highest degree of this polynomial. All right, and that's 3. All right, degree classification. All right, since we have um, the highest exponent is 3, the degree classification is a cubic. Okay, so the degree is just referring to that exponent. Right, the number of terms classification. So here we have negative 3y cubed and 8. So we have two terms, so that means this is a binomial. All right, and then written in standard form is we go in descending order of the exponents. So here our biggest exponent is 3, so we have negative 3y cubed first, and then we add 8. So this is actually already written in standard form for us. Okay, in the second example, it's asking us for the degree, the highest exponent, and notice that the highest exponent here is not in front, all right? So the highest exponent is 4. So our degree is 4. Degree classification, highest degree is 4, so this means this is a quartic. Quartic. And then the number of terms it has, we have 1, 2, 3, 4 terms. So if we have 4 terms or more, there's no special name, so it's just polynomial. And then finally, writing this in standard form means writing it with the exponents in descending order. So we start with our largest. So we have positive 3x to the 4th power. Our second largest is positive 2x squared. And then we have plus 6x minus 5. So now let's actually talk about how we are going to add and subtract these polynomials. All right, and it's important to remember that we can only combine like terms. Okay, so that means only combining like x squared stuff with x squared stuff, only combining x's with x's, okay, stuff like that. We can't combine an x squared and an x cubed, for example. All right, so to put words to that, like terms have the same variable raised to the same power. All right, and there are two methods you can use to combine the terms, and we're going to go over both of them. And the vertical format is you line the terms up vertically and add, and the horizontal format is you just add like terms, okay? And you'll be able to use either of these at any time, just whatever you're more comfortable with. Okay, so let's go over an example. So in the first one, we're going to use the horizontal format to add or subtract the polynomial. So one way to do this is first identifying all of the x cubed. So we have negative 7x cubed here. All right, and then that's the only x cubed we have. So this is going to be equal to negative 7x cubed. And then let's look at the x squareds. So we have negative 9x squared and 8x squared, okay? And keep in mind, we're adding these together. So negative 9x squared plus positive 8x squared is going to be negative 1x squared. So we can just write that as negative x squared. All right, then we'll identify our x's. So we have positive x plus negative 2x. All right, so 1x plus negative 2x is going to be negative x. And then finally, we have our constants. So we have positive 2 plus a positive 4. That's going to be plus 6. All right, and that's all we have to do for that one. Okay, for this next one, notice that we're subtracting. So what I'm going to do is I'm going to distribute that negative to each term. So I'm going to do some distribution here to each of my term inside the parentheses. And then I can rewrite this as negative 6x cubed plus 5x minus 3. Okay, and I'm distributing that negative. So if I have negative 1 times 2x cubed, I have negative 2x cubed. Then I'm going to have negative 4x squared, all right, plus 3x minus 1. So basically I just rewrote it and I flipped each of the signs in my second set of parentheses, so I don't need to worry about those anymore. And from here we can do the same thing we did in the first example. So I'm going to identify my highest exponents first. So I have a negative 6x cubed and a negative 2x cubed. So negative 6x cubed minus 2x cubed is going to be negative 8x cubed. Then I want to identify my x squareds. All right, and negative 4x squared is the only one I have, so I'm going to have negative 4x squared. And then my x's after that, so I have a positive 5x plus a positive 3x. So this is plus 8x. And then last I have my constants. So I have negative 3 minus 1. That's going to give me negative 4. So the first step of that problem, when we kind of distributed that negative, is we wrote this as an addition problem, okay? So whenever you're subtracting two polynomials, a good way to do it is just to write it as an addition problem, okay? That's the first thing you should do, and then you don't need to worry about that negative anymore. So that's the horizontal format. Let's talk about how we can use the vertical format, all right? So here, what I'm going to do is I'm going to write that first polynomial out. So I have 3x cubed minus 8x squared minus 5x plus 8. All right, so I just rewrote that first polynomial. And then I'm going to write the second polynomial below it, but I'm going to kind of line up the terms so they're below their like term. So like, let's see what that's going to look like. All right, so this first term is 11x squared. So I'm going to write 11x squared under my negative 8x squared from the first polynomial. Okay, and then I want to write the 4x next. So I have a positive 4x. So I'm writing that under the negative 5x, and then finally I have negative 2. All right. So we're just going to add these, okay? That's the operation we're doing here. We're adding. So 3x cubed plus 0 is just going to be 3x cubed. And then we have negative 8x squared plus 11x squared. That's going to be a positive 3x squared. All right? And then we'll have negative x and then plus 6.